Okay, so in this check, we're going to take a look at some basics of acids and bases. So the first thing that we want to know on the first question, so explain acids, bases, and pH. pH is actually a scale, and in the pH scale, we know that is on a total amount of 14. It's a logarithmic scale, and so we know that the pH plus the pOH is equal to 14. Okay. And so our scale is on a 14, and we know that when we add these two things up, they add up to 14. And so when we look at the far left of the scale, we're going to say that pH equals 0 down here, and on the other end, pH equals 14. And right in the middle, we're going to have 7. Okay? And so our 7 is neutral. So in the very middle, we're going to have a 7, and that is neutral. Okay. And at that point, that is when the concentration of H plus is equal to the concentration of OH minus. Less than 7, we are going to have an acid. And the acid is going to be where the concentration of H plus ions is going to be greater than the concentration of OH minus. And on the other end of the scale, we are going to have a base. And a base is going to be when the concentration of hydroxide ions is going to be greater than that of hydrogen, or hydrogen will be less than the concentration of hydroxide ions. An interesting thing about this scale is actually the inverse of this is going to be the pOH scale. And so pOH, this would be a 14 on the pOH scale, and then the other end, pOH, would be equal to 0. And so we can actually look at the inverse of that. Most of the time we look at the pH scale in its entirety. So let's just define really quickly what an acid versus a base is. There's a few different definitions. We really tend to work in the realm of either a transfer of hydrogens, and so we'll kind of take a look at a couple different things that we'll focus on, even though there's some additional explanations that are out there. But for right now, for us, an acid is going to be where you either have a hydrogen ion that has been donated, so we donate or release a hydrogen ion, H plus, in solution. And for a base, we're going to define that at this point. Oops. Let me grab my blue to represent our base. For a base, there are really two ways that we can look at this point. So one is that we release hydroxide ions, OH minus, or another way that we can look at these is they will accept a hydrogen ion in solution. Okay, so we have kind of two different ways of looking at that. Question 2 asks us to identify the acid, base, conjugate acid, and the conjugate base. So the acid and the base are always going to be on the left-hand side of whatever equation we're looking at. And so we want to look and see what happens from the left side to the right side of the equation. And so in this case, let's take a look at NH3. So NH3, from the left side to the right side of the equation, ends up gaining one hydrogen ion. Okay? So if it is accepting or gaining that hydrogen ion, then that means it had to be the base. So on this side, this is the base. And then what it becomes on the other side is going to be the conjugate. I'm going to abbreviate that, acid. So in the reverse direction, this is acting like an acid, okay? Or this is the acid in the reverse direction of this. So once we identify that this, the ammonia is the base, then what we can do is assume that the other one that is there would be the acid, okay? And so this H2O is an acid, and you have to be careful because water is able to act as either an acid or a base. But in this particular situation, H2O on the other side becomes OH minus, which means it has released or lost a hydrogen in this solution, and that makes this the conjugate base. All right, after that, we're asked to do some calculations. So let's take a look at a few of these calculations that we have to do. So in the first one, it says, what is the pH of a solution with a hydrogen ion concentration of 3 times 10 to the negative 4th? Well, we have an equation that we need to use, and that equation is pH is equal to the negative log for the concentration of hydrogen ions, H+. Okay, so this is our equation that we're going to use. And so we're just going to plug in our values here. So that means pH is equal to the negative log of 3.0 times 10 to the negative 4th. So I'm going to plug that into my calculator and see what we find. And so I want to hit the negative button, and then I want to enter in 3, and then second, and I'm going to hit that EE button on my calculator to the negative 4th. Oops, excuse me, clear. I have to hit negative log. Won't do much good if I don't do that. 3 second EE to the negative 4th. All right. So I enter that in, and I get a number of 3.52. I look, I only started with 2 sig figs, so I want to end with 2 sig figs. So we should end up with 3.5 for our pH. Now, if it's a pH of 3.5, let's go back up to our scale. Well, that's less than 7. So that means that 3.5 would be an acidic solution. And so we can go ahead and write that on here. This is an acid or an acidic solution. Just kind of so we keep that in mind as we're working through these different values. Okay, on the next one, we see that it's asking us for pH if we know the concentration, when we know the concentration of hydroxide ions. And so we're going to use POH is equal to the negative log of hydroxide ion concentration. So that is one of our equations. Go back up here, make that a little bit bigger this time. Okay, so this is an equation that we have. So let's go ahead and plug our values into there. Now that's going to give us POH, not pH. So POH is equal to the negative log of 3.0 times 10 to the negative 4th. I just used the same number value there. Okay, and so when I calculate this one out, POH, the negative log of that is still going to give us a 3.5, just like we got in the last equation. Now that is for POH, that is not pH, and so we have to then apply this equation as well. So pH plus POH equals 14. And so to find pH, we're going to have to take the pH is equal to 14 minus POH. Okay. And when we do that, pH is equal to 14 minus 3.5, and that equals 10.5. Okay. Now 10.5 on the pH scale or a 3.5 on the POH scale is going to be a base. So this is a basic solution. Just to kind of keep that in mind. You may not be asked for that necessarily straight up. Okay. The last equation or the last problem that we have to solve on this check is what is the hydrogen ion and hydroxide ion concentration for a solution with a pH of 4.6. So if we're going from from pH to the ion concentration, our equation is going to be that the hydrogen ion concentration is equal to 10 to the negative pH. Okay. And similar to that, the hydroxide ion concentration is going to be equal to 10 to the negative POH. Now, we don't have POH, but we have pH, and we know that 14 minus the 4.6 is going to give us a value of 9.4, and this is going to be our POH, okay? So the POH here is going to be 9.4. So we'll come back to that here in just a moment, but that's how we figured out the POH. Just going to kind of highlight just a little bit on those equations, and let's go ahead and solve these. So the hydrogen ion concentration, H plus, is equal to 10 to the negative 4.6. So in my calculator, I'm going to do 10, and then I'm going to do the up caret button, negative 4.6, hit enter, and I get that it's 2.5 times 10 to the negative fifth. So that big E that we see there is times 10. So the hydrogen ion concentration, H plus, is equal to 2.5 times 10 to the negative fifth. Okay. And then I want to find out my hydroxide ion concentration. So OH minus is equal to 10 to the negative POH. Oops. Let's go ahead and plug in the value that we have for that, which was the negative 9.4. We'll just put that right in there. So 9.4, and when we calculate that out, we will do 10 up caret negative 9.4, enter, and we get 3.98, so I'm going to round that up to 4.0 with sig figs, times 10 to the negative 10th, and I guess I should put molar on there. Let's go ahead and put our unit on there so we make sure we have that as well. And that is how we solve those.